So chapter 11, chapter 11.1 particularly involves systems of equations, and there's several different techniques for solving systems of equations that you've seen in Algebra 1, Algebra 2, maybe geometry, depending on what class you've taken so far. But we're going to basically start from the basic level of this, and we're going to move ourselves up to a higher level than you've seen ever in any of those classes. So this kind of is all the possibilities basically that can happen with systems of equations in chapter 11 here. We're going to start, this lesson is going to seem really easy to you. I would say the first couple days of this will, and then as we get to day 4 and 5, then you'll start seeing some stuff that's a little bit different than you've seen before. Using the same basic concepts, it's just making it a little bit more abstract. So, with that in mind, verification of a solution. This is just a basic skill you want to have with systems of equations in order to help you know whether or not your answer is right. So they're going to give you a problem that looks like this. You're going to solve that problem. You're going to get an answer which is an ordered pair. You want to make sure you're right. You verify a solution. The ordered pair that you get represents x and y. And if it is the solution of this system of equations, that means if I replace the x and y in this equation, I get a true statement. If I replace the x and y in this equation, I get a true statement. If they're both true, then it isn't a correct answer. If it's not true in both, it's not a correct answer. And it could be true in one but not the other, so it has to be in both. So make sure you check both. So if I start off by checking this top equation, according to this, 2x plus y is supposed to equal 11. So 2x, I'm going to put parentheses for x, plus y, put parentheses for y, equals question mark 11. So we're questioning whether or not this is a true fact. And we're going to substitute for x, we're going to put 4. For y, we're going to put 3. So 2 times x, x is 4 from the ordered pair, plus y, y is 3 from the ordered pair, is supposed to equal 11. We don't know that it equals 11 yet, so we're questioning it. If we calculate the left-hand side using order of operations, 2 times 4 is 8, and 8 plus 3 is 11. 11 equals 11 is a true statement, which is what we're looking for is truth. If we see truth, we're good to go. If that was false, if it said 15 equals 11, or negative 2 equals 11, or anything other than 11 equals 11, you'd immediately say, this is not a solution. All right, if it doesn't work in one of them, it doesn't work at all. So, again, the fact that that's true means we move on to the second equation. If that happened to be false, then you would just stop right away and say 4, 3 is not a solution. Then we move on to 4y minus x equals 8. So again, 4 times y minus x is supposed to equal 8. We're going to question that. All right. So notice the order of letters here. Y is in the first term, x is in the second term. So again, x is 4, y is 3, no matter what order they put the letters in your problem. So x is 4, that goes right here. Y is 3, and that goes right there. So we replace x and y where they belong. Again, order of operations, 4 times 3 is 12. 12 minus 4 might equal 8. And 12 minus 4 does equal 8. Okay, so 11 equals 11 is true. 8 equals 8 is true. Both statements came out true with this ordered pair. So we can say then our answer will be 4 comma 3 is a solution. Again, if any one of those was false, you would say 4 comma 3 is not a solution. So those are your two possible final answers. Either ordered pair is a solution or ordered pair is not a solution. I'm looking for truth to say this. Either one of those is false, I would say it is not. And again, I would expect to see your work shown to verify that is what you did.